look like to you?
Beads.
Some beads? Look at those beads. What do you think those beads are made of?
Wood.
They're all wood?
Those who work with young children recognize the difficulty they have understanding adult concepts. Their reasoning is often different from ours. In this film series, we will draw upon the work of Jean Piaget to show the internal organization of child thought and its gradual progression towards adult forms. The apparent inaccuracies of child thought are part of a pattern through which all children pass.
Off of the necklace.
That's a worm.
Worm? Okay, we'll take the beads off the worm. Put the worm around like that so that none of them get away. And let's stand them up like that. Would you help me do that? Stand them up.
This film explores 3 stages in the development of children's classifications and reasoning about classes. Classification is critical to all thought. Each stage of classification has its own character and organization, and each new stage is an advance over earlier ones.
5, 6, 7, 8, 8.
Okay. Are there more red beads or more yellow beads or the same number of each?
More red beads.
Beads. Okay. What were the red ones made out of?
Wood.
And what were the yellow ones made out of?
Wood.
Okay. Now, what would happen if I took all the red beads away? What would be left?
The yellows.
And what would happen if I took the yellows away? What would be left?
The reds.
And what would be left if I took away all the wood beads?
There would be none.
Okay. Are there more red beads or more wood beads?
What?
Are there more red beads or more wood beads?
More red beads.
More red beads. Okay.
4-year-old Ian realizes that if all the wooden beads are taken away, none will be left. Yet he tells us that there are more red than wooden
What would
beads.
happen if I took all the red
This
beads
illustrates a
away?
type of reasoning belonging to the preconceptual stage.
And what would
This
happen
is a
if I
stage
took
of
the
mental
yellows
development
away?
through which all children pass.
The reds.
It's a particular type of thought with its own form and organization.
Okay, Ryan, tell me what we have here. What is it?
Ryan, an 8-year-old, reasons differently from Ian.
Red and yellow.
Uh-huh. And what are they made out of?
Wood.
Huh? Are they all made out of wood? What do you think?
Yeah.
How about the yellow ones? Are they made out of wood too?
Yeah.
Okay. Now I have a question for you. Are there more wooden beads here or are there more red beads?
Red.
Are there more red beads than wooden beads? And why do you say that?
There's more red than yellow beads.
Yes, but is there more red beads than wooden beads?
No.
Why do you say that?
Because if you just see that red off, then it'd be just plain wooden beads.
They'd be wooden beads. So which is more, wooden beads or red beads?
Wooden.
And what is the reason for that?
Because all you have to do is just get something to take this off, and then they'd be just plain wooden beads.
But if you took the, if you
Ryan
took the-
knows that there are
bead
more
off of
wooden
these
than red
ones,
beads.
but if
He
you took the
shows
paint
that he
off
can
all the
consider
red
all
ones,
the
you
beads
still
as
have
red
one.
and yellow, and at the same time consider all of them as
Now, I'm
wooden.
gonna ask you some more questions.
This reversibility of thought characterizes the concrete operational stage
Well,
to
let's
which
leave some-
Ryan
we'll just leave
belongs.
it on, actually, in this-
1, 2, 3, 4, 5, 6, 7, 8, 9.
4-year-old Darylyn provides more insight into the nature of the young child's thought. She calls all the beads bean beads.
Did you tell me they were all made out of beans?
Yeah.
Okay. Are they bean beads? Would you call them bean beads then?
Bean beads.
Bean beads? Okay. I need to know if there are more bean beads or more red beads.
More red beads.
Why do you think that?
For most 4-year-olds, a class such as wooden beads is a spatial collection. When asked to consider the red beads, the group of wooden beads is mentally separated so that only the red and yellow beads exist. These groups are what both 4-year-olds compared. Ian is asked to put together shapes that are alike.
Shapes together again. Would you help me?
The careful placing of objects in lines and the fitting together of triangles shows that for Ian, classes are tied to their appearances or spatial arrangements. Because of these characteristics, classes formed by children in the preconceptual stage are called graphic collections.
You think you could put some more things with my groups? Okay, would you do that for me?
Ian builds a tower of shapes, adding each shape because it matches some object in the group, rather than sharing a common property with all the objects in the group. Darylyn, too, is asked to put together things that are alike. Darylyn's collections are also graphic. This is revealed in a number of ways. The squares are carefully aligned with each other. The adding of small squares creates a nice spatial symmetry.
Okay.
Triangles are added to the arrangement of squares because they add to the spatial symmetry. The square does not visually fit the circles.
What about the other thing?
Darylyn ends with a number of graphic collections. While the collections are of different shapes, they are similar in appearance, and each pile fits together as a spatial
Tell
whole.
me what you did. Tell me what you did.
Those stick together, together,
Uh-huh.
together, 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 together.
Uh-huh. Why did you
For the
pick
preconceptual
these
child,
things to put in
the
this-
very act of grouping objects is often enough to define a
You
class.
wanted to? Okay.
Later in the interview, Darylyn continues to form graphic
Where's
collections.
the others? Oh, where? Oh. Where are they?
I don't know what that was.
Other shapes are added to the squares, as if Darylyn is trying to create a visually interesting whole rather than a class.
There you go. I want to go.
Now Darylyn combines shapes according to their color. The graphic nature of the classification is shown by her careful arrangement of blue and red squares around the color piles. A concern with appearance and arrangement rather than similarities and differences has dominated Darylyn's classifications. This is a clear indication that her notion of class is graphic and belongs to the preconceptual stage of thought.
Well, this is a horse.
The stage following preconceptual thought is called the intuitive stage. The child becomes increasingly concerned with classifying according to the similarities and differences between objects.
Here is a man that's bringing a bucket of water.
Okay, good.
And another man that's bringing a bucket of water. And here is a pig. And this is a man with a...
The man with a rifle is kept separate from the men with buckets.
Okay, so those things that are alike, put them together in a group.
The growing concern with similarities and differences leads to a beginning struggle with higher order classes. These classes are composed of subgroups that are different from each other, but also similar at a higher level of abstraction. For example, tables and chairs can be combined in the class of furniture.
Go here.
While 6-year-old Miles can form classes of similar objects, the symmetrical arrangement of the babies shows that appearance and arrangement still play a role.
This goes right here. This gets the next three. Next go right here. And these all go right here.
Marvelous. Those are marvelous things. Now, you have a lot of different piles here, and I'm wondering if you could put things together for me so that we have less groups. Put things more together. And why are you putting those all together?
So the people could sit right here. This. Right there. And this.
Very good. You did a very nice job of setting the table. That looks just like it's about...
When asked to combine groups, Miles creates a graphic collection, the arrangement of a table
Is there
scene.
anything else that we could put over here with this that would be alike this in some way?
This. Right there. And this. And this.
And how are those alike?
See, 'cause they walk up to the table and start eating.
Does that make them alike?
Mm-hmm.
All right.
And this.
And what can we do with, can we take this apart and put this into different piles?
Yeah. Like this.
Miles shows that he can break this graphic collection into the original classes defined by the similarities and differences between objects.
And then take these two plates. These.
Okay, and what about the table? That stays by itself? Okay, marvelous. Now last time, Miles, we had a table set with the chairs and the plates and the people there. We had some animals and we had the baby cribs. Okay, so that was 3 groups of things. We had the furniture, the animals, and the people. Okay? This time I'd like you to be able to put on these pieces of paper for me. See where we're going to put the paper. 3 groups of things all together, but different than before. On this paper, I want all the things to be alike in some way. And over here, I want all the things to be alike in some way. But I want these things to be different from these things. Can you do that for me?
These should go right here.
Okay.
Like that. And then...
This task requires Miles to combine some of his groups to form higher order classes. He instead places already formed classes on the 3 pieces of paper and leaves a remainder of objects to be sorted.
And what about these things here? Is there anything you want to do with those, the remaining things that are on the table? Is there any place we can put them?
Yeah, well, we could put these right up here. These right up here. Like a T.
Make a T. Okay, so you're not going to put those on the paper.
No, you shouldn't, because then...
Miles is unwilling to put the table with the chairs because of the differences in appearance, even though both are furniture.
Because then those would be mixed up with all these.
Okay, what if I give you one more piece of paper? Is there some way that we could put all of the things on pieces of paper, keeping these groups the way we have them?
Like this, and then these like this, then this right here, then the silverware right over here.
And what about the glasses? What are you going to do with those?
Put these right over here. One over here.
Now, how is everything on this piece of paper the same? I can see how these are all animals, but I don't know how everything on this thing is the same.
But these could be the same.
Okay.
'Cause
What could you
these
call them?
You could call
Things to eat with?
You could call these silverware.
Yes.
Mm,
Did we drop the knife?
yeah. You could call these silverware, and these plates, and these cups.
And is there something that we could call all of them?
Uh-huh.
What?
Could call this something you eat with, and this also.
They're all
And
something
this
to eat with?
something to drink with.
Yes.
And this something to help you eat.
Okay, now, is there something, could we do something, let's take these off of here, and these off of here. What I'm going to ask you to do is divide up the remainder of these things so that some of them are on here and some on here, with all the things over here the same and all the things over here the same.
Rather than anticipating how the remaining objects could be grouped into 2 piles, such as furniture and utensils, Miles starts by placing things that are alike on the 2 pieces of paper.
And take the silverware, put them over here.
And what are the things on this piece of paper?
These are things to eat with. This
Okay.
helps you eat.
Yeah.
And these are what you sit on, and these two help you eat too.
Very good. And what are you going to do with these things over here? What can we call those?
Well, we could take these and put them over here. Take the one up there. We could call these cribs.
Marvelous. Okay, we got everything into 4 piles. Very good.
Ryan's earlier thinking about the wooden bead problem showed that he is at the concrete operational stage of thought. We therefore expect Ryan to show more advanced classifications than we have yet seen. Ryan quickly classifies the shapes according to similarities and differences. The letters, however, offer an obstacle to his classification. He eventually forms a variety of small classes, including letters of the same color, groups of similar letters, and graphic collections in the form of words.
We have 20 piles of things. I'd like you to make it for me so that we have less piles of things.
How many?
Well, make them less. I want you to put things together more than they are right now.
Okay.
Could you put some of these piles together? Would it be all right to put some of these piles with each other?
That's what I am finna do.
When asked to combine his groups, Ryan instead reclassifies all the objects on the basis of color.
All blue.
Arrangement is not important in Ryan's classification of blue objects. Ryan ends by dividing the color groups into smaller classes of letters and shapes.
Group of red letters. And a group of yellow letters.
Now I'm going to ask you another difficult one to do. Remember before we had just 3 piles, and what were they? You had made just 3 piles for me? Do you remember what, could you give me a name for each one of those piles? We had a pile of all blue things,
Yeah, a pile of all red and a pile of all yellow.
and we had 3 piles. I'd like you to try to make for me another situation where we have just 3 piles, everything in 3 piles, but this time a different way.
Okay. Okay.
Now remember, we want to end up with just 3 piles.
Oh, just 3 piles.
All together, just 3 piles. We already have one of them. We have the pile of letters.
Ryan struggles with forming 3 classes on the basis of similarities and differences. Having classed all the letters together, he is faced with the difficulty of constructing 2 classes out of the remaining material.
Wait a minute. Wait a minute. These are the piles of shapes that all people heard of, and these are the shapes
That people haven't heard of.
that people have heard of. A lot of times, these are the shapes that people haven't heard of that much.
That is a marvelous solution. That's certainly not one I had ever heard of before or thought of before, but that does do exactly what we wanted.
Ryan's unique solution reveals the flexibility of concrete operational thought. Darylyn and Ian are typical of most 4- and 5-year-olds. They are in the preconceptual stage. Their classes are called graphic collections because appearance and spatial arrangement of objects is the basis of their classifications. When asked to put together things that are alike, the preconceptual child may group objects that go well together, look good together, or form a nice pattern. As a result, a graphic collection may contain a variety of dissimilar objects, or contain objects that are similar to those in other classes. The nature of graphic collections leads quite naturally to reasoning about classes in a way that is markedly different from adult thinking. Ian and Darylyn both argue that there are more red than wooden beads because the spatial nature of their class concepts leads them to compare only the red and yellow beads. The intuitive stage, to which most 6- and 7-year-olds belong, is illustrated by Miles. Children in this stage can classify objects according to their similarities and differences. However, this is just beginning, and children in this stage have difficulty combining groups to form higher-order classes. Difficulty also arises when the child must anticipate how a set of objects could be divided into a given number of classes. Around 8 years of age, most children enter the concrete operational stage. During this stage, classification takes on an increasingly systematic character. Ryan is just entering this period. He knows there are necessarily more wooden than red beads because all of the red beads are only some of the wooden beads. He can also combine groups to form higher order classes and at the same time break these into subclasses. This ability to reason about the relationships between classes makes it possible for Ryan to invent unique yet systematic solutions to classification problems. The development of thought goes through a series of stages, each with its own form of reasoning. Piaget has shown that this developmental progression is not unique to individual children. It is universal and marks a progression whose natural course is towards increasingly systematic and internally consistent thought. The child encounters the world at his own level of development. Before passing to the next stage, the child must first experience the world through his own eyes. Reasoning that appears illogical to the adult may be perfectly natural to the child. It is his way of seeing and will only progress if it is used. It is necessary for the child's development that he be allowed to explore his own view. In this film on classification, we have examined one area of development. Other films in the series cover additional topics, showing that for each there is a natural and similar progression of stages, leading towards more accurate and systematic ways of seeing the world.